Okay, so now we're looking at how do we draw structures and how do we name the alkenes from structures. Okay, so let's first do let's first see how we're going to draw the structures for different sort of alkenes. So let's take, okay, let me just mark this, how to draw structures. Okay, so let's say you have a CH4. Now CH4 is pretty easy. So you have a C and you have to show 4 bonds of hydrogen. Okay, so this is a CH4. So if we talk about now C2H6, so you'll have 2 carbon molecules. You'll draw the 2 carbon atoms, you'll draw the 2 carbon atoms first, and then you will place 3 hydrogens with each carbon. And the reason why there is 3 hydrogens is because here you had one carbon, and that and since we know that the carbon can make 4 bonds, so those 4 bonds were made by 4 hydrogens. Now here, since you have 2 carbons attached to each other, so now you know that 2 bonds are occupied here and here. So that means now these 2 carbons can combine only form 6 bonds. So one carbon can make 3 bonds with the hydrogen and the other carbon can make 3 bonds with the hydrogen. Why? Because 2 carbons that are attached with each other have one bond occupied with itself. Okay, so this is C2H6. Okay, now let's see C3H8. Now the C3H8 means you'll have 3 carbons, molecules like this, atoms like this. Sorry, again, I keep saying molecules, and then you're going to have the structure like this. So all you have to do is make the carbon chain first. Make the carbon chain like this. There's something that we call the carbon chain. Make the 3 combined carbon chain first, and then what you're going to do is to place hydrogens. In an alkene, is pretty much very easy. You just make the carbon chain and then you just place the hydrogens according to their bonds, and it's pretty easy. It's going to get a little bit tricky in alkenes because there's double bond involved, but in carbons it's pretty much easy. And even if you want to count the bonds here, so let's say you want to count the bonds. Okay, so let me just highlight this here. So we say that one carbon can make 4 bonds. So here is the one bond, here is the other bond, and here is the third bond, and there is the 4 bond. Okay, so one carbon has now here made 4 bonds. Now let's take a look at this carbon. So this carbon has one bond here, one bond here, one bond here, and one bond here. Okay, so this makes 4 bonds. Now let's talk about this carbon. Now this carbon has one bond here, one bond here, one bond here, and one bond here. So all of these 3 carbons has individually formed 4 bonds and combined has formed 12 bonds. Okay, now let me just go downwards and let's look at C4. Let's look at C4H10. Again, draw the carbon chain first, and then all you have to do is to make the hydrogens. Pretty easy, right? Let's draw one more after this, and then we are done with the structures for alkenes. Okay, so this is C4H10. Let's draw C5H12. So this is 1, 2, 3, 4, 5, and this is 1, 2, 3. This is 1. This is 2. This is all the hydrogens are being placed here. So this is how we have drawn the structures. Now, using these structures, how can we also name them? Okay, let's take the example of methane first. Let's take the example of CH4. So let me just change the color here so that we have a little bit of differentiation. Okay, so let's look at this one. So now we know that here the number of carbon atoms is 1. So carbon atoms being 1, that means the molecule is going to be meth. And since there are all single bonds here, you know that this is going to be the homologous series of alkene. So this is a methane. In a similar fashion, here The number of carbon atoms are 2, which means this is an eth molecule. And since it has all the single bonds, we know that this is an ethane. Here the number of carbon atoms are 3, so this makes it prop. And since we know there are all single bonds, this makes it propane. Similar way, let's go down to the other ones. Okay, sorry, yeah, let's go down to these ones. Now, number of carbon atoms are 4. This means that this is going to be a but molecule. And how we have all the single bonds. So this is a homologous series of alkanes, which means that this is a butane. Here, the C5 means number of carbon atoms are 5, which means that the name is going to be pent. And since there are all single bonds again, this is going to be a pentane. If we had C6H14, pretty easy again, N is equals to 6. We know that's a hex by the prefix. And since this is a homologous series of alkane, we are going to know that this is an ane. Now, figuring out whether this is a homologous series of alkane has two ways. Either what you can do, let's say if I have to figure out the molecular formula for this, what I can do is that either draw the structure. So let me just quickly draw the structure for this. Okay, so if I draw the structure here, consider these all the hydrogens. Okay, so if I draw the structures here, you can see that these are all the single bonds. So one way is a detailed way is this. The other way is that you can just simply place this into the formula CnH2n plus 2. So you know that the number of carbon atoms are 6. So N is equals to 6, C6H2, 6 plus 2. So this is C6, this becomes 12 and plus 2 becomes 14. So C6H14, and now you know since that this has satisfied the equation, this is going to be an alkane molecule. Okay, cool. So this is where we end this part.